Dashidalik once again. I'm going to continue from the topic of motion itself. For today, our learning outcome will be about acceleration, and we will try to learn some of the graph in the form of distance time and velocity time. So we will go for the acceleration. Okay, normally we experience this kind of situation in our life whenever we are traveling in a bus or in a car or in a taxi, whatever it may be. For example, we try to fall forward, like forward, and we try to fall backward also, and sometimes we try to fall to the back on right side, sometimes to the left side. We experience this kind of situation when we were traveling in any kind of automobiles, right? So when do we experience such kind of situation? Fall forward, for example, if you are traveling in a bus, if the bus driver decided to put a brake, then we begin to fall forward. And if all of a sudden the bus driver he started to speed up, all of a sudden, without our own knowledge, what we used to do is that our body we begin to push back. And if the driver serves to the right side, we begin to fall to the right side, like in the same way, right? So all these things are happening. Why? Because there is a change in velocity which is taking place. There is a change in velocity. Whenever there is a change in velocity, these things happens over here, right? So now, I guess every one of you are quite familiar with velocity here. Now, what is velocity? Which we had done yesterday, or day before yesterday, we talked about velocity. Velocity is nothing. It is a speed with direction. Speed with direction. So now in this kind of situation, this situation happens. Why? Because there is a change in velocity. And this change in velocity is nothing, is speed with direction. So whenever there is a change in velocity, we say acceleration occurs. Right? Acceleration occurs. So now you might be thinking, what actually is that acceleration? Right? So let's go for it. Suppose to imagine, okay, this is a car here. There's a car. There's a car. And this is the position over here. A, B, and C. Right? If this car is traveling at a speed of 80 km per hour, in 1 hour, this car is going 80 km. And the moment when this car reaches at this position, again this is 80 km per hour. And even at this point here, see, 80 km per hour. In this case, do you see any kind of acceleration? No. So what actually is acceleration? Because whenever any kind of object travels at a uniform speed, there is no acceleration. So now you must be thinking, what is acceleration? Acceleration is nothing. It is a rate of change of velocity is referred to as acceleration. Let me write on top here. This is how we used to define acceleration as the rate of change of velocity. For example, A. Now let us imagine, okay, there is a person who is running, and he is running at a velocity of let's say 20, let's say 2 meter per second, 2 meter per second. Now suddenly what happened? This guy, what he did, he speed up, right? He increases velocity or speed with another kind of like thing here. That is 4 meter per second in that direction. So now, as I said, that this guy now is running in this direction over here, and that too with a certain amount of change in the speed. So I have already said before that whenever there is a change in speed, we used to call this as velocity. Now this is velocity here. So now previously when we were talking about velocity, we have discussed about two things here. One is initial velocity and what is the final velocity. Now over here, this is the initial velocity, that is u. And over here, this 4 meter per second is the final velocity, that is v. So now this is how we are going to write. Now suppose imagine from here, this position to that position, he is changing some speed. Now we already know that whenever there is a change in speed, there is always some time over here. That is 4 seconds. That is another 4-second time, because time is always going to be there, right? So this is how we define rate of change of velocity. That is change in velocity, to the time is what we call as acceleration. So now over here the u is 2. Over here this is 4. Now what is the what do you call change in the velocity? How much is the change in velocity? So definitely what you're going to do, you're going to subtract 4 minus 2, that is 2, right? So how we are going to write here? A is equal to, how we are going to write here? That is v minus u upon t, right? So how much is v? V is 4 meter per second. And how much is u? 2 meter per second. In a time interval of how many? 4 seconds. Right? So 4 minus 2 is how much? 4 minus 2 is 2 meter per second. Divided by how many? 4 seconds. We are somehow getting answer in 0.5. That is 2 1 so 2 to the power half is 0.5 meter per. There is 1 second already over here, and there is another 1 second by meter per second. This second also belongs to meter per second. So second multiplied, that is meter per second square, is the unit of acceleration. So acceleration normally, the SI unit is meter per second square. Is that clear? Okay. So this is in the case of acceleration here, right? Okay. Yes. Now talking in terms of graph here. Graph. Okay. So now we will talk about graph. So normally in class 9 we discuss graph in the form of two things here. Number one is distance versus time graph, and second one is velocity versus time. So now first we are going to talk about distance versus time. Okay. Time. So now we know that already we had the concept of speed. When we were learning about speed, we came to know that in speed there is a presence of two kinds of physical quantity. The quantity number one is distance, and quantity number two is time. So when we were writing about distance and time, somehow we will understand that we are talking about speed, right? So now I'm going to write in this format here. Okay. So now y-axis, x-axis. On this side, I'm going to write distance s. Letter S symbolizes distance, and this is time. On this case also, right? Okay. So here, now this is the situation over here. If any kind of object, for example, on a straight kind of highway, if a particular kind of object covers equal amount of distance in an equal interval of time, that means we talk about uniform motion, similar to that of uniform motion. If any kind of object covers equal distance in equal interval of time, that means we are going to get a graph like this. That is a straight line graph, which we used to call as uniform speed graph. This is the uniform speed graph, right? Okay. Now we are traveling from one place to another place where there is a lot of turns and everything. So what we are going to do in that case, we won't be able to cover the equal amount of distance in equal interval of time. But rather what will happen is that in a 1 minute, we are able to cover 1 meter, 5 meter. In the next 1 minute, we may cover 2 meter. That means there is a change. So whenever this kind of situation arises, we have this kind of graph, which we used to call as non-uniform speed graph. Non-uniform speed. Now the third one is the condition where suppose imagine I'm standing over here right now. When I'm standing over here, am I covering some amount of distance? No, distance is zero because I'm standing at one stationary position. But what about the time? Time will keep on going, right? Because it will not wait for me. For example, right now maybe it's 9 o'clock in the morning. Now, if I wait for another like 1 hour, it'll become 10 o'clock. Then later, like though I won't be covering any kind of distance, but the time will keep on moving on. So I'm going to write here the distance they are not covering, but the time here, time moves in that. This kind of graph is referred to as object at rest. Whenever the object is at rest, we draw this kind of graph here, right? So this is a three graph in the case of distant time. Understand? Okay. Now let's go for the next one. Second part of the graph. That is velocity time graph. So now velocity time graph, because in the case of speed, we discuss distance and time. In the case of velocity, we talked about displacement versus time. Now in the case of like acceleration here, we talked about the change in the velocity with time. So now over here, there are two physical quantities which are present over here, that is velocity and time. So naturally, we will be talking about acceleration over in this case. So here, there are two kinds of graphs which we can draw over here. So graph number one, and we'll write it in that way. This is the velocity. This is the time. Okay. Now, in this case here, velocity time graph, the situation is like this here. In this direction. If an object or a bike, let's imagine a person is riding this bike. Okay? If he is running, if this bike is moving at a speed, a very high speed with a certain amount of direction, with an acceleration of 2 meters per second square, 2 meters per second over here, this position A. Now at the same position B, he should be traveling at 2 meters per second square. That means accelerating. Please don't mistake acceleration with speed. Normally, the student make a lot of misunderstanding that when an object is traveling at a high speed, that means it's acceleration. That's not the case. Acceleration can occur even with an object traveling at a very low speed too. Understand? So what we are more concerned about is the change in velocity over here. Understand? So uniform, this kind of graph here, in this case here, In this kind of like graph, what we are indicating is that the object, like this kind of object, the bike, it is moving at position A, B, and C with same kind of acceleration, that is 2 meters per second square. Same kind of acceleration. Is that clear? Understand? So these kind of thing is referred to as uniform acceleration. Uniform acceleration. In this case, for example, okay, an object is falling down from the sky. This object is falling down from the sky. For example, this chalk is falling down from the sky. This object, regardless, because there is a presence of gravity, is going to fall down, and it will fall at a constant acceleration. So normally, in the case of Earth, this is 9.8 meter per second square. We know that, right? Okay. Now, in the case of the second one here, for example, okay. Okay, Kenson is riding bike. The moment he come across the what do you call that speed breaker, naturally he has to reduce his speed. So whenever we are, because I guess many of you are quite familiar with riding bike. So on a bike, you can see to the right hand side, you find a kind of like a certain kind of thing called accelerator. Accelerator. Even in automobile also, right? Taxis, we have accelerator. So accelerator means to increase, right? To increase. So this accelerator, for example, whenever we come across this speed breaker, what this bike is going to do is that maybe he will apply his brake, he will decrease his acceleration, then again he will increase his acceleration the moment he crosses this. Now you can see over here, this guy may be like at 5 meter per second square. Now we cannot expect him to be over here 5 meter per second square. Over here maybe 1 meter per second square. Then suddenly he will increase to 3 meter per second square. So you see three different kind of values here. In that case, this is what we call as non-uniform acceleration. Non-uniform non-uniform acceleration. So these graphs are very important. In exam, they might ask you to write a graph for an object which is at rest, or write a graph for an object which indicates that the object is moving at a uniform acceleration. So this is the part of today's lesson. So during your here, so like just share so the curriculum and acceleration of graph location and acceleration that the ones who color it. You see, what you get velocity and get show speed with direction can show about speed with direction. You see, initial velocity, the final velocity for Jubatia by now. Dini Porudella, Tuzi Jubatia by now. Oh, acceleration now. Wow, acceleration the unit curriculum once you meter per second square of keyboard. Wow. Those shit. And these are also graph layer. Graph now to get show you know distant time graph down, velocity time graph new distant time because you know distant the time you speed joy is and once you speed uniform speed down, non-uniform speed and object at rest so many watching today. Whereas velocity time graph thing was acceleration case and then acceleration number rate of change of velocity with time dimension now what it means and velocity acceleration now once again the graph need to match you. Those things that English goes into the situation. Thank you.